Okay, 4.3 is talking about vertical and horizontal translations. So remember from the previous sections that if we have y equals a sine of bx, then we know the amplitude is a, the period is 2 pi over b, and now what we're going to get is called a phase shift. Sometimes you might also call it a vertical translation. So we now have this c value that we're adding to them. So my phase shift ends up being the opposite of c, so negative c divided by b. And then we get something called the endpoint. And I like to know the endpoint because my endpoint is my period plus my phase shift. It helps so when I plot those 5 points that I know which 5 points to plot and where I'm supposed to end. Okay. Now why is it negative c? Remember we had a rule for all of algebra 2 that said if we take a variable in or out of parentheses with a variable, then we have to flip its sign. Same thing. If I'm taking c out of a variable or out of a parenthesis with a variable x, then I have to change his sign. Okay. And remember when you slide things left and right on a coordinate plane that it does the opposite of what you think it does. Okay. So let's graph here number 1. It says y equals sine of x plus pi over 2. Okay, so we still know our amplitude from before is still 1. My period, I can put a 1 there if I want, but my period is still 2 pi. So this guy is 2 pi over b, so 2 pi over 1. My phase shift is negative c over b. So negative pi over 2 over 1. So negative pi over 2. So my endpoint is negative pi over 2 plus 2 pi. Well, when I do that, I need a common denominator. So negative pi over 2 plus 4 pi over 2. So this guy is 3 pi over 2. All right. So 3 points along my y-axis. I'm going to start at 0. Positive 1, negative 1. Now, the phase shift is your first point. So this guy is actually negative pi over 2. So I put the y-axis there. If you want, you can move it over, and I'll show you here in a second. But the end point is 3 pi over 2. Okay, now I need to find the guy in the middle of that. So I'm going to take negative pi over 2 plus 3 pi over 2. The denominator is the same. So negative 1 plus 3 is 2. I can cut that in half. So this guy is 1 pi over 2. All right, negative pi over 2 plus pi over 2 is 0. Cut that in half, it's still 0. Looking at my numerators or my fractions again, I have 1 pi over 2 plus 3 pi over 2. 1 plus 3 is 4. I can cut that in half. So this guy is 2 pi over 2 or just pi. All right, so essentially we've moved our graph. Like here is really where this is the origin here. Okay, so if you want to put that on there, you can. I don't need to see it, but you might have math teachers in your life that need to see that. All right, so this guy is sine. Sine starts at 0. 1, 0, negative 1, 0. Connect the dots. Give him a curve shape. And so you're just going to graph one cycle. Okay, so how's that different? How's number 2 different from number 1? Well, this guy now has a plus sign. Or a minus sign. So he's going to be moving in the opposite direction. So my amplitude is still 1. My period is still 2 pi. But now my phase shift is a positive pi over 2. So 2 pi plus pi over 2. So 4 pi over 2 plus 1 pi over 2 is 5 pi over 2. One, 0, negative 1. This guy is now starting at pi over 2. So you can think about over here would technically be my origin. Again, I don't need to see it, but you might have math teachers that want to see that in your life. Okay, they have the same denominator, so I can add them together. 1 plus 5 is 6. I can cut 6 in half, so he's 3 pi over 2. 1 plus 3 is 4. Cut 4 in half, so 2 pi over 2. So pi. So that guy's pi. 3 plus 5 is 8. Cut 8 in half, so he's 4 pi over 2, or just 2 pi. All right. Now, he's still sine, so 0, 1, 0, negative 1, 0. All right, next one. Just getting lots of practice graphing today. All right, 3 sine of 2x plus pi over 2. Amplitude is 3. Period, 2 pi over 2. So pi. Phase shift, negative c over b. So negative 1 pi over 2 times 1/2. So negative pi over 4. Notice if it's a positive, then our phase shift should be negative. All right, negative pi over 4 plus pi. Well, that's 4 pi over 4. So 3 pi over 4. All right, my amplitude is now 3, so I'm just going to say 0, and I can change the scale to whatever I want, so I'm going to say that guy's negative 3. Phase shift is negative pi over 4, endpoint 3 pi over 4. All right, negative denominators are the same, so I can add the numerators together. Negative 1 plus 3 is 2, cut it in half, so that's positive pi over 4. Negative pi over 4 plus a positive pi over 4 is 0. Cut 0 in half is 0. All right. 1 plus 3 is 4. Cut 4 in half, so he's 2 pi over 4. Or pi over 2. Still graphing sine. 0, positive 3, 0, negative 3, 0. Curve shape, add in your, oh, that was wiggly, arrows, and make him curved. That one's a little pointy. I don't really like that. He shouldn't be a V shape, so you're not going straight up V. Yeah, it's a curve shape to it. All right, ooh, we got a cosine here. So now we have 2 cosine of 3x plus pi. All right, amplitude's 2. Period is 2 pi over 3. Phase shift is negative c over b. So negative pi over 3. So 2 pi over 3 plus a negative pi over 3 is 1 pi over 3. All right, here we go. Amplitude is 2. 2, 0, negative 2. Negative pi over 3. Make sure I can see that's negative. Positive pi over 3. All right, cut it in half. Negative 1 plus 1 is 0. Cut it in half is 0. Negative 1 plus 1 is negative 1. I can't cut the top in half, so I'm going to double the denominator. So negative pi over 6. Same thing, 0 plus 1 is 1. Can't cut that in half, so I'm going to double the denominator. Okay, now he's cosine. Cosine starts up, so positive 2, 0, negative 2, 0, positive 2. Curve shape going back down. Again, not a V. Give him a curve. Peaks and valleys going back down. All right. Number 5. 4 sine of 2x minus pi over 3. So my amplitude is 4. My period is 2 pi over 2, so he's pi. Phase shift. This guy's now a positive pi over 3 divided by 2. So pi over 3 times a half. So pi over 6. Now, if your period has a pi in it, your phase shift should have a pi in it. If the period doesn't have a pi, then the phase shift should not have a pi. So you shouldn't be adding like 2 plus pi over 3. All right, so pi over 6 plus pi. So that would be 6 pi over 6. So 7 pi over 6. All right, 0, 4, negative 4, pi over 6, 7 pi over 6. All right, denominator's the same, so I can add them together. 1 plus 7 is, oh, where'd you go, friend? 1 plus 7 is 8. I can cut 8 in half, so that's 4 pi over 6, which is 2 pi over 3. So I'm going to write 4 pi over 6 down here because we're going to need them. So when I add them together and do my little half the top, double the bottom, the denominators have to be the same, okay? So I can't add 2 and 1 because those denominators aren't the same, but I can add 1 and 4, which is 5. 5 can't cut in half, so this guy is 5 pi over 12. Again, I can't add the 2 and the 7 because the denominators aren't the same. But 4 plus 7 is 11. I can't have the top, so I'm going to double the bottom. 11 pi over 12. All right, this guy's sine. Sine starts at 0. Positive 4, negative 4, 0. Ooh, what did I do? That ain't right. 0, negative 4, 0. That's what I meant to do. Again, curve shape, not V's. Add arrows at the end because he repeats. Okay, here's a tricky one. Now I got a negative 4 cosine of 2x minus 3 halves, 3 pi over 2. All right, so my amplitude, remember, amplitude's still positive, but it's got a negative 4. That's okay. Period. 2 pi over 2, so pi. Phase shift, negative c, so he's going to be a positive 3 pi over 2 over 2. So 3 pi over 2 times a half, so 3 pi over 4. So 3 pi over 4 plus pi, 4 pi over 4, so 7 pi over 4. So 0, 4, negative 4, 3 pi over 4, and 7 pi over 4. Okay, denominators are the same. 3 plus 7 is 10. I can cut 10 in half, so I get 5 pi over 4. Denominators are the same. 3 plus 5 is 8. Cut it in half, so I get 4 pi over 4, which is just pi. 5 plus 7 is 12. Cut 12 in half, and I get 6 pi over 4, which is 3 pi over 2. Yes, I want you reducing all your fractions because I know you can. Now, he's a negative cosine. So when we were doing cosine before, he would start up at positive 4. Well, now we're going to do the opposite. So he's going to be reflected across the x-axis. So negative 4, 0, positive 4, 0, negative 4. All right. Number 7. Negative 5 sine of 1/2 x plus pi over 4. So, again, amplitude's always positive, so he's 5, period, 2 pi over 1/2. So 2 pi times 2 would be 4 pi. Phase shift, negative c over b. So negative pi over 4 times 2, so negative 2 pi over 4, so negative pi over 2. Okay, my endpoint is my period plus my phase shift. All right, well, that would be 8 pi over 2, so 7 pi over 2. 5, 0, negative 5, 7 pi over 2, negative pi over 2. All right, negative 7 plus 2, negative 7 plus, no, Negative 1 plus 7 is 6. Cut 6 in half, so I get 3 pi over 2. That one is okay. Negative 1 plus 3 is 2. Cut that in half, 2 is 1 pi over 2. 3 plus 7 is 10. Cut 10 in half is 5 pi over 2. Okay, now he's a negative sign. So 0, now I'm going to go down. 0, up, 0. So again, anytime there's a negative out front, make sure you graph him reflected across the x-axis. So, can you identify the phase shift for a sine or a cosine function? I sure hope so. All right, now what happens when we add these numbers out front? So this guy says negative 3 plus 2 sine of pi x for 1 cycle. This is going to move my graph up and down. So these are my vertical translations. So I'm moving my graph up and down instead of horizontally now. We could be doing both. So this guy, if I had something in the parenthesis, I would have a phase shift. So for this guy, I don't have a phase shift. So my period and my endpoint are going to be the same. Okay, so my amplitude is the number right in front of the trig function. So my amplitude is 2. My period is still 2 pi over b, so 2 pi over pi. So my endpoint is the same as my period. My vertical translation, this guy is now my vertical translation. So I'm going to move my graph down 3. He's going down because he's negative. Okay? So this is going to be my new starting point. My new starting point is negative 3, and my amplitude is 2. So if I go up 2 from negative 3, this guy's negative 1, and I go down 2 from negative 3, he's at negative 5. So this is 0, 2, half of 2 is 1, half of 1 is a half, 1 plus 2 is 3, double the bottom. He's sine, 0 up, 0 down, 0. So we moved our whole graph down. So my x-axis is technically right there. Like that's where my origin is. All right, number 9. It says graph 3 plus 5 sine of pi x minus pi over 4. This has everything. This is all of it. Okay, so my amplitude is 5. My period is 2 pi over pi, so 2. My phase shift is negative c over b. So negative pi over 4 times 1 over pi. Pi's are going to cancel, so my negative 1/4. 2. I'm going to do it over here. My endpoint 2 plus a negative 1/4. Times it by 4, so 8/4. So 7/4. Now, we have vertical translation. This guy's positive, so we're going to say up 3. Okay, so this guy's 3. My amplitude's 5, so I'm going to add 5 to it, so I get 8. 3 minus 5 is -2. This guy's -1/4, positive 7/4. The denominators are the same, so -1 plus 7 is 6. Cut it in half, 3/4. -1 plus 3 is 2. Cut it in half is 1/4. 3 plus 7 is 10. Can cut 10 in half, so that's 5/4. And finally, this guy is sine, so 0, up, 0, down, 0. Yowzer. Oh, hey. Back this way, friend. Add some arrows, give him my curve shape. There we go. All right, so can you find the vertical translation of a trig function? I sure hope so. That's that number out front. If he's positive, you're going to add it. Oh, this should be up 3. If he's negative, you're going to go down 3. I can graph a sine or cosine function, have a phase shift, and a vertical translation. That's what we just did in number 9. All right, the value k in y equals k plus sine of x represents a vertical translation. If k is positive, the graph will be shifted k units up. And if k is negative, the graph will be shifted k units down. The h value in y equals sine of x minus h represents a horizontal translation. If h is positive, the graph will be shifted h units left. And if h is negative, the graph will be shifted h units to the right. So the graph of y equals sine of bx plus c will have a phase shift of -c over